right, so 6.3.2, another normal distribution problem. So the mean mathematics SAT score in 2012 was 514 with a standard deviation of 117. And we're told to assume that the mathematics SAT score is a normally distributed random variable. So once again, we're asked to state the individual, the variable, type of variable, and the random variable, and then to list the givens from the problem with the correct symbols. So in this case, an individual is going to be a randomly selected person who took the SAT. And the variable that we were looking at for each of these individuals was their mathematics SAT score. And so that is usually based on the number of questions you got correct. So I'm just going to put that in here. So based on number of correct answers. So this is going to be a quantitative discrete random variable. And so our random variable x here is going to look at the mathematics SAT score. So there's our measurement there that we're looking at of a randomly selected person who took the SAT. Now again, to be more specific here, we could add, in 2012, because that's what this data is based on. And then our givens, again, when we're talking about a distribution, distributions are for populations. And so we're looking at our symbols here, mu, or mu sub x, was given to be 514, and sigma, or sigma sub x, was given to be 117. Okay, so although we have a quantitative discrete random variable here, we're going to find out that for a lot of just quantitative random variables that we do use continuous distributions as close approximations for those probabilities. So for part B, it says to find the probability that a person has a mathematics SAT score that's over 700. So again, we're going to start by translating that statement into a mathematical statement. We want a probability, so P parentheses, and the math SAT score is our random variable x, and we want that to be over 700, so to the right of 700 on the number line. So again, we're going to begin with a picture. So again, our normal curve here is centered at 514, so there's our mean. And we want to the right of 700. So again, on this graph happens to be from StatCrunch, so it is using on the axis here the tick marks, at 1, 2, and 3 standard deviations away. Okay, when you're asked to make these sketches in homework, you don't need those. You can just put in your 514 and a representative, 700 to the right of that, and in this case, shade the left tail. So this is our quick sketch as we make them in our homework. All right, so on the TI-84, we would want to compute the probability of getting x greater than 700. And actually, let's go back up here for just a second. In our list of givens, we're going to put here, they did tell us that we have a normal population. That's what allows us to use the normal CDF to get these probabilities. So on the TI-84, to get the probability that x is greater than 700, we're going to use normal CDF. Again, from our picture, we can see that the shaded region reading left to right starts at 700, runs off to infinity. Again, you can't get an infinity for a score on the SAT, but again, the mathematical model that we use to describe the situation, those normal curves extend on the x-axis from negative infinity to infinity. And then our mean that they gave us was 514, and the standard deviation was 117. Okay, so this comes out to be about 0.0559, or about 5.59%. So again, if we were to interpret this, okay, there is about a 5.6% chance that a randomly selected person who took the SAT scored above 700 on the math SAT. Okay, so that is above 5%, so this is not unusual.